Okay, and we are going to continue with standard practices for defining pipelines, and Andrea Frittoli is going to tell us about how it's possible to define pipelines using Tekton.
Hello, my name is Andrea Frittoli. I'm a developer advocate at IBM, and I'm a member of the governance team for the Tekton project. Today I'm going to talk to you about scaling pipelines with Tekton. I'll show you how scaling a successful scaling strategy starts right from how you write your pipeline and through the way you run them. I'll discuss some of the possible bottlenecks that you may hit when running pipelines with Tekton, and hopefully at the end we'll have some space for Q&A. But first, a small step back, give you an introduction about Tekton. So Tekton is an open source framework for creating CI/CD system, as it's written on our website. Main advantages is Tekton is cloud native, so it runs natively on Kubernetes, which provides you a serverless environment for execution of pipelines, scalable one as well. Tekton aims for standardization and giving built-in best practices when running your workflow. One of the core tenets of Tekton really is maximum flexibility in the way you set up your workflow with Tekton. Tekton is made of different projects, the core ones being pipeline and triggers, plus we have some toolings like CLI and dashboard and operator, and we have some project dedicated to discovery of tasks and adds on that I will discuss more in details later. Tekton comes originally from the Knative project, where it was called Build and later Pipeline. And finally, it evolved in its own project and hosted by the Continuous Delivery Foundation. So Tekton, in fact, is one of the founding projects of the foundation. Tekton works by extending the Kubernetes API with what are called custom resource definitions. So Kubernetes provides a set of abstractions called resources, like a pod or a service or a deployment. And what Tekton does is creating new resources that are specific to running tasks and pipelines on a Kubernetes cluster. So Tekton defines things like a task, which is a collection of steps or containers, a pipeline, which is a collection of tasks, and then this allows you to define your pipeline, and then to execute them, we have new resources that are called task run and pipeline run, which are the runtime. The static definition is bound to the execution through a set of resources like parameters, results, and workspaces that defines inputs and outputs of the various parts and how they are connected together. So when it comes to authoring pipelines, Tekton strategy is about reusability, providing building blocks. I already mentioned steps, which are typically off-the-shelf containers, container images that provide a certain functionality that can be used in your pipeline. You can have also small scripts that you want to ideally avoid having like big chunks of Python or Bash embedded into YAML. So I already mentioned tasks as well. Tasks typically aim to solve one specific problem. So they are focused on an area which can be owned by a team or an individual who is the expert in providing a good solution for that problem. This allows for distributed maintenance of your task of different part of your pipelines, as you can have different tasks maintained by different groups. So for reusability to work, though, you need to have a few things. First of all, you need to have discovery. So if you're writing your pipeline, you want to be able to have access to the different components that you want to use, the building blocks that you want to use to build a pipeline. Second, you need to have versioning because you might rely on a specific task, but that task is maintained by someone else. So if a new version of the task is modified, you want to make sure that this does not have direct impact on your pipeline. And lastly, you want to have execution efficiency, because if you break down your pipeline in tasks and steps, so a lot of small building blocks, and you have an overhead in starting up each of these building blocks, then you might end up with a pipeline which is slower to execute than you would wish for. So what are Tekton answers to this? In terms of discovery, task definition can be deployed to a Kubernetes cluster. There are resources and can be discovered there. Another means of discovery is through the catalog. So we have a community maintained catalog, which is a Git repository where we have a set of tasks that can be used when authoring pipelines, as well as you could have your own organization or team catalogs. And finally, we have the hub, an API, which is an API with a dashboard on top that allows you to search for tasks and download them into your cluster to use them. In terms of versioning, it might be visible here in the screenshot of the hub. We have in the catalog, we have version associated to tasks. So when task is modified, we create a new version and put it in a different folder. Another approach that we are experimenting with is what we call Tekton bundles. So the idea here is that we upload one task or a set of tasks into a container registry as artifacts. And there we basically win the ability that you have in a container registry to version. So you can tag a bundle, you can have a SHA associated to it as well. And we introduced in the Tekton controller the ability for a pipeline to download a task from a bundle at runtime. So this makes it hopefully very smooth experience when we're using tasks, and it allows you to specify in your pipeline that you want to use a task at a specific version or SHA. We are also working on a CLI to make the authoring experience easier. In terms of execution efficiency, we have a few strategies that we are working on. One is task specialization. So if you want to have if I have a task, but I may want to run it in different contexts. So for instance, with data that comes from a PVC, or maybe the data that comes from my local laptop. So you want to be able to specialize the task and not have many different versions or many different tasks that need to be combined to achieve this. Another thing that we're looking at is the ability to run multiple tasks in the same Kubernetes pod or node, but I'll talk more about this later. So in terms of pipelines, can they be a building block, something that I can reuse and share with others? Well, if you look at these pipelines, it is quite large, and it's actually not so uncommon to have pipelines even larger than this. So sharing pipeline, it is supported by the catalog. However, when you have such a large pipeline, then you may run into issue if you want to swap one of the blocks. For instance, you have a new version or change one of the implementation in one of the blocks, or you want to add a new branch into the pipeline. Then you run into this kind of issues because the overall workflow may be owned at the end by different teams responsible for different parts, and different bits in your pipeline may have access to different resources, maybe different secrets. They may run in different namespaces in your cluster, or they may even need to run on different clusters, which would not be possible with a single pipeline in Tekton. And so if you want to change your pipeline, then you may have to get many teams involved and many difficulties. So you might think of breaking down the pipelines, but you still want to have one workflow. So how do we connect then all the parts? And here, this takes us to the running bit of the story. So typically, a very common use case is that you would run a pipeline as a reaction to an event, and we have one project in Tekton which is dedicated to solve this problem, which is called triggers. triggers is able to receive an event, which is an HTTP post, something that could be like a webhook that is triggered when a pull request is created or an image is published to a registry, for instance. And this event is then can be filtered, validated through interceptors, and then data is extracted for binding, and resources, so like pipeline run or task runs, are created with templates. So this allows us to run the pipelines. And once the pipelines and task execution are complete, or also when they start or while they're running, we are able to generate events. That could be Kubernetes events or cloud events, a CNCF project. So these things combined together means that we can receive and send event as a reaction to pipeline. So which means we could rework the pipeline we show earlier into a more complex pipeline, such as this kind of composite workflow where we have one initial pipeline, some bits below, a different pipeline which may be even running on different platform. Like we have a Tekton here on the left, and then we have Captain on the right, and we have some tests which are executed with Jenkins. So what is the advantage of this approach? So as I mentioned earlier, we may have different ownership. So maybe a team is responsible for everything which is deployed to production, and then that is handled by the captain. Or maybe they already have a solution for that, and we want to connect it to something that comes more from the CI side of things. So we don't need to rewrite the captain pipeline. We can combine the two pipelines together through an event. We may have a bunch of test suites already running in Jenkins, and maybe we want to trigger them, and we may want to incrementally add tests, and that is owned by a team which writes a test, and they don't need to worry about changing the core pipeline to do that. They just receive the events and trigger extra pipelines, for instance. So this provides a number of benefits, this approach. But there are also some issues. First of all, you may need to have like custom integration. So yeah, we send events and we can react to events, but if you have different platforms, do they understand events generated by Tekton, or does Tekton understand events generated by these platforms? And also in terms of orchestration, you kind of lose the overall orchestration provided by the pipeline abstraction in Tekton. So how do you make sure you still have visibility across your entire workflow when it's run this way? So this is one of the problems that the Events in CI/CD Special Interest Group is trying to solve. This is a group that is being formed within the Continuous Delivery Foundation, and it is looking at how to standardize the protocol for communication and the architecture for communication through events in CI/CD. So look at that space if you are interested in this area. So this takes us finally to the bottlenecks that you might encounter when writing or running your pipelines with Tekton. So I talked about growing pipelines and very large pipelines, and I need to get a bit deeper into the implementation in Tekton to explain this one. So when we have a pipeline in Tekton to reconcile it, so to execute it, we basically transform it into a directed acyclic graph, where each node of the graph is a task, and the tasks are connected. The nodes are connected to each other with a connection that are made between tasks and dependencies between, for instance. And so we came at some point where we had very large pipelines, maybe 100 of nodes densely connected with a lot of connections. And we started to see that we had startup time for the pipeline that would grow almost like exponentially. So the pipeline, before it started, it may take seconds or even minutes, close to an hour before it would start. And then again, one task was executed, and then it would take again longer time for the next executions. So because pipeline is a resource in Kubernetes, it means that it goes through what are called reconcile cycles. And reconcile cycles is what they try to converge the definition of the pipeline into what we want to actually run. But the only shared context between reconcile cycles is what is defined, the status and the definition of the pipeline, which means that every reconcile cycle we need to rebuild the DAG. So what it turns out that we had some suboptimal code in the DAG computation, which was causing the time that it takes to compute the DAG and to check for the lack of cycles to grow exponentially. So luckily that was just a bug, and that is now solved, and we don't have any bottleneck anymore. You can have easily a pipeline with many hundreds of nodes, and it just runs normally like a smaller pipeline. But more issues may occur when you're under pressure, so running actually multiple pipelines concurrently. So for the scheduler, we rely on the Kubernetes scheduler today, which means that if you try to schedule more and more pipeline and you don't have any more resources in the cluster for that, the Kubernetes scheduler will put the execution on hold automatically for that. And one of the things that is very important when working with Kubernetes is to use the informers. So we had to change a few things over time to make sure that everything, all the requests to the Kubernetes API go through a cache of the API so that we don't hit the API directly, because that would have an impact on really a negative impact on scalability when you start having many pipelines running concurrently. Also, we have the ability through leader election, which is a functionality provided by Knative, to scale our controllers horizontally. So we can have many of them, and they will break down the different pipelines into buckets. So each controller is responsible for a set of the data of the pipelines to be executed. Potential enhancement that we could do in this area are things like throttling pipeline execution. So limit the execution, the number of pipelines we can run concurrently. And also we have been talking about a custom scheduler. At least it is an idea that has been proposed, but we are still considering. In real life, we use Tekton to build and release Tekton, and we run thousands of tasks a month in the community in upstream, and that works pretty well. At IBM also we offer Tekton as a service, and there we run millions of containers per month, and that works pretty smoothly. In both cases, though, we have some kind of throttling implemented on top, which could be from what we do at IBM. We limit the maximum number of pipelines that we run at any point in time in the cluster, or in the community, we limit the people that can run pipelines. So only maintainers or people within a trusted group can run the pipelines, and other, when they submit PRs, for instance, they need to be authorized before the pipeline is executed. And this helps us to protect from attempt to denial service by proposing multiple PRs and malicious PRs. Another issue that we've seen in real life is cluster pollution, because every time you run a pipeline, then a pipeline run is left in the cluster, which grows the space that is used in etcd and makes it slower to list resources from the cluster. So it's a good practice that we found that you need to clean up the cluster periodically, even though that is the downside that it kind of loses your execution history. So one of the things that we are working on in terms of upcoming feature is Tekton Results, which provides an off-cluster, so at least, could be a different cluster, or it's not CRDs, an off-cluster storage for your execution history. And also we have some work that is starting in terms of performance testing and improvement of the metrics that we provide, so we get more granularity in what is going on. In terms of data and IO, I mentioned earlier execution efficiency. So we have a bit of trade-off between reusability and efficiency. Today, tasks are implemented as Kubernetes pods. And as you may know, a pod is scheduled by Kubernetes on a node, but multiple pods may be scheduled on different nodes, which means that common tasks are things like cloning a Git repository, building a container images, downloading some content from an object storage, run some tests, and things like that. But then if you then want to do something very common like cloning a Git repo, build a container image from it, and run some tests, these are different tasks that may end up running on different nodes in your cluster because they're different pods. So it means that you need some storage to share a little between them. So you might need something like a PVC, which has provisioning time. It's an extra resource that needs to be consumed. It requires extra I/O because you clone the repository and then you have to copy it into the shared storage and then download it from there. So you get extra I/O, extra execution time. So this is not true for all the type of data that you have in pipeline. So we have some metadata, and for that we have a solution which is what we call results. Results are stored in the status of the resources, so they can be shared between tasks without the need of extra storage. But for large type of data, we need to resource to things like workspaces, which are an abstraction around PVCs. So we have some alternatives that we are working on to solve this problem. One idea could be to change the minimum entity of reusability, which is a step. So to share a step scripts. Another way would be to run reusability to run multiple tasks in a pod, or maybe to have different dedicated scheduling capabilities so that we schedule, for instance, all the pod within a pipeline that need to share data on the same node, and that might require things like a custom scheduler. So this is everything that I had for you today. So thank you for listening to my talk. We should have a little bit of time for questions still. I wanted to mention that the slides are on GitHub. Here is the link if you're looking for them, and then you can get all the other links and references as well. And please come and join us at the Tekton community. And thank you again. Goodbye.
Thank you, Andrea, for a very interesting talk. I'm super excited to hear about the effort on standardizing the events. Actually, continues our discussion with Andreas about standardization, which is super cool. It's awesome that these efforts exist, and hopefully we're going to have even more of them. Looks like you've answered a bunch of questions, so then I'm going to go ahead and ask a few more. So one question would be, when defining the pipelines, one of the ways to achieve better scale is through incrementality. And usually to do that, we try to leverage caching. And for example, every node, if its inputs do not change, can potentially just spit out the output that it had already produced for the previous runs based on the same inputs. So I wonder if you have explored some of the ideas around incrementality and doing automated node output caching based on inputs.
We are exploring those. We got some use cases from, like you mentioned, and we've got some users that are working in the area of MLOps. And for them, it's very important as well because they usually have very large artifacts. So we are exploring things like the ability of checkpointing a pipeline or storing artifacts midway, or the ability to start a pipeline at any place. So at any point, not from the beginning, reusing artifacts that were produced by a previous run. So these are the features that we are looking into. We are working on the design for those kind of features.
Awesome. And do you support heterogeneous pipelines where, for example, different nodes can technically be operating on different platforms? Let's say parts of the platform is going to execute on the Mac, and part of the pipeline is going to execute on Linux. Some pieces are going to execute to Windows. But basically, depending on the type of resource, we may leverage a different platform for the computation. Do you support something like that?
Right now, we run on top of Kubernetes. So we are constrained by the nodes that you can run on the containers that you can run on Kubernetes, on your Kubernetes cluster. You can use Affinity to bring your nodes to bring your workflow to nodes in your cluster that have special capabilities. If you need special hardware on certain nodes, and the things you can do, you can use events to break your pipeline in multiple pieces that might run on separated cluster where you have like ability to run different kind of workloads, like you mentioned, Windows versus Linux versus Linux.
Yeah, I mean, this is actually a common, I guess, challenge with, so there is the orchestration and there is also choreography. And obviously, if you rely on events, you get a much more decoupled architecture, but at the same time, it's much harder to do some things that require some sort of centralization. Even simple things like, for example, visualization. So how do you strike the balance? Like how do you, how can you provide a very good visual, for example, graph-like visualization for your pipeline if it's defined mostly through the events?
So that's one of the reasons why we're joining this effort in standardizing how we work with events in CI/CD, because we believe that it's important for this kind of decoupled workspaces, workflows, to have a common format and standards so that you can build tools to visualize the overall workflow. So we don't have a way to visualize this specifically for Tekton, and I think it would be nice if we were able to build it more for the overall community, if we understand the ways to connect the workflow between not only Tekton but also Tekton and other platforms. So things that we do, when we trigger pipelines, we tag them. So we actually add labels that corresponds to an event ID that was the trigger for the pipeline, and we propagate those labels through all the resources that I generated. Those labels are also sent through the events as metadata, so you can apply them again, and you can use this to search through your cluster and identify all the tasks and pipelines that are specific to a certain workflow. But we don't have dedicated orchestration, a dedicated visualization tool to help you with that yet. We are working towards standardizing.
Yeah, that's actually an interesting thing. Obviously, it's possible to use something like a distributed tracing to visualize the workflow as it happens. But if you have a very, very loosely coupled architecture, then doing the visualization beforehand, so basically like showing what would happen before you even start execution, is much trickier, obviously. And so I guess the last question I had is, it seems like for a lot of efforts like this, and there is a significant amount of overlap, and I wonder if you've looked at the specifications for workers API or remote execution API that Google is using for distributed build systems like Blaze or Bazel, and it's actually been slowly adopted by other build systems and other tooling.
Right, we not looked at Bazel specifically. I know the system, but we have not looked at that specifically. We wanted to focus on a CI/CD specific use case, and we want try to provide kind of a standard layer that could be used, if you will, like as a middleware by other tools as well to build on top. So that's,
yeah, I mean, yeah, it makes sense. I mean, I'm not saying like that's actually the thing about the Bazel, is that the workers API, they have nothing to do with the build. It's just basically resource provisioning API that is very, very low level. And the remote execution API also doesn't have to do anything with the build. It's basically just like you define a command, the inputs, outputs, and that's it. So this way is just a very useful way to decouple the resource provisioning from the command execution and then from the scheduler. So all these layers, they are in no way connected to the build. They are mostly just, I guess the scheduler is going to operate on the DAG, which is exactly what you have, right? Because you operate like the pipeline is there. But otherwise, it's pretty much not related to build itself. It's just build happens to leverage the same graph-like structure for dependency management as the pipeline, but there is nothing inherently specific to the build itself.
Okay, that's very interesting.
Yeah, well, looks like we're again a little bit behind time, but first, I hope we're going to have you at the panel discussion in an hour or so. So thank you so much again, and I'm looking forward to continue the discussion with you in an hour.
Thank you.